Hello everyone, thank you very much for joining me again for this first episode in which we discuss fundamentals of software architectures. Uh, in this series of episodes, we'll discuss about software architecture, about architects, what kind of architects we have out there, what do they do. We'll discuss about class design, the difference between design and architecture. And we will mainly focus on Java technologies, but that's only because I am a Java developer, so that's my background. But I will have to claim this software architecture is not dependent on a specific technology. So even though my examples will be using maybe most of the times using Java technologies, architecture in general is agnostic. So most of the principles and ideas I'm discussing here, they do apply in any platform and on different platforms. Okay, so I see you have no sound, even though I find out something here. So can everybody confirm there is sound only on the left side? Okay, that can be my problem. I'm not sure if I can solve it now. Probably my audio is on stereo. I won't be able to solve it now, but I promise that I will solve this in my next episode, because otherwise I would have to restart. But I promise I will solve this problem, so no worries. Okay, if you will listen it on speakers, it should be no problems. If you put your headphones, then indeed it might be a little bit nasty. Sorry for that. So thank you very much for noticing, by the way. So I will continue now, and I was saying that we're going to discuss all these important notions that they do apply not only on Java, in the Java ecosystem, even though being that my background is as a Java developer, you will mostly see examples from the Java ecosystem. Now we will discuss about the difference between an architect and a developer. You will see that there are a lot of things that are misunderstood out there, for example, many people consider that an architect is necessarily some kind of an developer plus plus. You know, it's some kind of a level one more level above development, which is, you will see, not necessarily true. It can be, but it's not necessarily true. And of course, what I would like to, you already see that I have my eyes on the live chat and I see everything that you write there. So if you have questions, we can make this a discussion. This is why the event is live. And of course, if you don't watch the event live, if you see it recorded afterwards, you will be able to find me always on Twitter, on LinkedIn, or leave me the comments in the comment section under the video on YouTube, and we will discuss this as well. So let's make it as much as possible discussion. And we start today, and let me share you my screen, because we're going to work on plenty of diagrams. Sometimes you'll also see code during these episodes, but in most cases we will discuss a lot of concepts and ideas about software architecture with diagrams. By the way, I'm not claiming now that I will make you an architect after you will watch this series of videos, because software architecture is complex and it takes time and experience to understand everything. But there are some things that, from my point of view, any developer, any IT people should know. Like, even if you're a tester, you are a software developer, or maybe you are an architect, you need to know some fundamental principles, and this is basically what we are going to discuss in this series of episodes on the fundamental of software architecture. So that being said, let's start with the discussion first on what actually an architect is, and then we'll go into the architecture, the main architectural styles. that you need to know. Yes, probably both sides are working because now the microphone is just in front of me, so you probably hear me well just because of my position, but I will make sure that in the next episode you will hear me well, no matter if I'm speaking that way or that way. I wasn't attentive to that. We will discuss about software architecture, and we start the discussion with what a software architect is. And first of all, I'd like to mention that we discuss in general about 3 levels of software architects. So we have the enterprise architect, we have the solutions architect, and we have the role of a technical architect. So in our series of videos, we'll mostly discuss about technical architecture, so we won't touch the solution architect's role and the enterprise architect's role, because, and I will explain now what's the main responsibility in a few words for each of these roles. So the technical architect is that person taking care of finding the best technologies and the proper way to fit them one with the others in applications, in systems in general, so that everything works well in terms of both functional and non-functional requirements of an application. So when we discuss about choosing a version of a specific technology, choosing a specific technology in general, when I say I want to use Spring in this application, and this application will make use of Spring and Spring Boot and Spring Security, that's an architectural decision taken by a technical architect. That's any time you choose something like I want to use Datadog for monitoring, or I want to use Dynatrace. If I say I want to use Kafka, or I want to use JMS. If I say I want to use JPA, or I want to use JDBC to connect to my database. If I say I want to use MySQL, Postgres, Oracle, or MS SQL, then these are all technical decisions that are taken by technical architects in general. So that's what we'll focus in this series of episodes on, how you take such kind of decisions and how you can fit these technologies together based on the requirements for a specific software, so that your software is the best. And what you will learn is that there is no perfect software out there, and whenever you take such decisions, you do compromise, you make compromises, and these compromises will affect the software qualities that you deliver. So the software is not only functional, but it has some qualities that are non-functional, the way we call them non-functional. These are, for example, performance, security, maintainability, usability, and so on and so forth. So you will never be able to make all of these perfect. So you have to make, first of all, be sure that your software is functional in terms of requirements. If the requirement is that 1 + 1 equal, it has to add numbers. That basically, it actually means that it actually means that you have to make sure that it's as performant as possible, as maintainable as possible, as usable as possible, and so on and so forth. So you will not be able to make it perfect on all of this, and you will have to make compromises if performance is more important than maintainability, for example. In some situations, in some cases, you might choose that you want to write some more code, and maybe have some duplicated code for some reason, because that makes your app more performant. And say suppose in your situation performance is more important than maintainability, then of course then you will have to make your app more performant, otherwise it might not be usable for the end user. So then you have to do this compromise. And this art of making compromises between software qualities by the way you implement the system is basically what a technical architect is doing for their living. Then you have the solutions architect and the enterprise architect. I will describe these roles, both of them, very fast, because again they are not what we want to discuss in general. These are not our main purpose of this stream. The solutions architect is that person making sure that teams that implement different solutions work well together. So for example, if you have a couple of teams, they implement two different solutions, they have contracts between their solutions, because maybe what one solution produces is consumed by another. So these applications in the system, they kind of work together, and they have to work together correctly and in a good way. And to make sure that you properly integrate the components of a system, to make sure that's working correctly, you have a solutions architect that facilitates the communication between the teams. I said two teams, but they of course usually are more than two in a system. They might be plenty of teams. And you have this person taking care of the communication between the teams. It's a very important role, actually. It's in all these three are roles, so that means that in some cases one person might have both the technical architect role and the solutions architect role. So that could happen. And I didn't find quite maybe in startups, but I'm not sure if in a big company you will ever see the situation where the enterprise architect is also solutions and technical architect, because there would be too many roles and too many responsibilities. But the enterprise architect in general is taking care of the processes of that organization. So it can be, for example, in some organization that the enterprise architect role is even taken by the CTO. So these are the three roles in software architecture, and we will focus on the technical architectures and we'll discuss architecture and design. So allow me make this a little bit smaller now, because we already discussed the subject. And again, I already mentioned, we already discussed what software architecture is. So in the position of a technical architect is basically making sure you can build your app as good as possible in terms of the compromises you have to make to be sure that your software is not only functional, but it also fulfills all the non-functional criteria. So from the very beginning you have some specifications, like say security. It's one of my favorites. If your app needs to be secured because you have multiple users and only some specific users can do some specific actions, then this is part of the non-functional criteria. So for example, if you have an application and it has to store some data in a database, if it manages to store the data correctly and maybe it processes the data correctly, but it doesn't fulfill all the security requirements, then it's still not functional considered. And what a technical architect does, it makes sure that it brings and it uses the proper technologies depending on the requirements, both functional and non-functional, to make sure that it gets a good application in the end. Good. Now, we can't discuss from the very beginning directly about software qualities. If I'm now going to take I don't know, software qualities like performance or scalability or security, because that's what we're going to do at some point. But if we are taking them from now without discussing at the very beginning some possibilities that you have to build the systems to achieve them, then it's a little bit more complicated. And I would prefer to take some time first in the say first episodes, first lessons, whatever you want to name them. We will discuss some architectural styles and then communication possibilities between components. And once we finish with all these Lego pieces that you can use to build the system, then we have the main Lego pieces that you can use to build the system, then we can discuss about how to use them and how they can be used to gain a specific software quality. So that's how we're going to discuss in this stream. Now, first of all, let's discuss about styles, architectural styles, and the way they appeared in the history of software development and software architecture. Sometimes it is also important to know how did some technologies or techniques appeared in software development and software architecture, because it happens that you might work also on legacy components. So today we have plenty of cases where specific organizations have both legacy code as well as new code that they have to maintain. So what you will observe is that you basically have to maintain code that has been written on literally a timeline of maybe 25 years. So maybe it might be that a specific component of an application has been started many years ago and it's still there, and you still have to maintain it. And understanding the history and the way some decisions, some techniques and some technologies based on which you take decisions appeared is very beneficial, and it helps you when you have to investigate a specific problem or maybe need to take a decision that affects a legacy component of your system. And again, this is something that really happens in real world, so it's a quite good skill to have. We will start with the discussion about monolithical, and we will discuss what a monolithic or monolithical application is. And then we will see what a service-oriented architecture is. And then the service-oriented architecture is kind of large. It has kind of a large scope in general. But today we very often discuss about microservices, which is say particularization of a service-oriented architecture that we will discuss. And then an even more particular service-oriented architecture you can consider what we call functions as a service. So that's how we're going to discuss the software architectural styles. So again, let me make this a little bit smaller. And the service-oriented architecture is something that in plenty of cases you will see it for short described as SOA, service-oriented architecture, and function as a service, which is part of a trend that we name today serverless, is very often shortened this way, FAAS, like function as a service. So what basically a monolithic application is, we will start with the monolithic architectural style because this is also the oldest one from the forementioned architectural styles. And there is an important reason for why this monolithic style is there since forever in software architecture. So it's the first architectural style. And there is also a reason why you still have, and maybe there is not only one, maybe there are more reasons actually for why we still have monolithic applications in the real world systems today. And first of all, I would like to mention that the monolithic architectural style is not something that is wrong. It's not something that is equal to legacy or deprecated, and it's something that you might still use and you might still decide to use today, even though many in the past few years, let's say like that, in the past few years there are many people and many speakers and many authors claiming somehow that a monolithic architectural style is a wrong style, and I've seen that and I don't agree with that, and during these episodes I will discuss with you why I don't agree with this this statement, and you will see that choosing a monolithic architectural style really makes sense sometimes. And I will tell you that in most cases a monolithic architectural style tended to be considered by developers wrong or equivalent to legacy, just because all the old applications usually fashion a monolithic style, because this was the first style to be adopted in software development. A monolithic application is simply an app where only one process implements multiple responsibilities. So I usually draw this like this way. I have a rectangle and this is my process. This is only one process. And inside it you have multiple responsibilities, or if you want to name them like this, multiple functionalities. Are monolith based on Spring framework a good idea nowadays given the framework's capabilities? The answer is yes. In general, our software architecture is agnostic by a specific technology, so even if you will hear me referring to Spring and to Java technologies, again I would like to mention that most of the things that you learn here are not necessarily linked to Spring or to other technologies. But now to answer precisely your question, you might choose to implement, still choose to implement monolithic architectures with Spring, because for specific reasons that we will discuss one by one here. Now, because it's very difficult to tell me to tell you where would you choose that. If we progress on the stream, you will see that monolithic applications have their benefits, and for those benefits sometimes you decide to use a monolithic architectural style instead of a service-oriented architecture, even when you use a modern framework like Spring. So even if you use the latest Spring version. So that's very fast my answer, but that we will get of course more detailed the more we discuss this stream. Okay, so then I draw different rectangles here, and these rectangles, they represent functionalities. I need to be more precise. I need to give you an example, because if I don't come with an example, you will only see some rectangles here, and I don't want that. I want this to be really clear. So let's say this is an online shop. Anyone can imagine online shop. Probably everybody used an online shop already. So online shop. So you have this kind of an application where you can sell different products, and you allow your user to register, and once the user is registered, they can add products that they can see in their cart, and then at the end they can pay everything, and they will get a delivery notice and the products will get delivered to them. So a very simple example that I guess anyone can imagine. But in case of an shop, you of course have multiple responsibilities. I have already enumerated some of them. So first of all, you might have an administration console that can be used by the administrator of the online shop to add products, change prices, add promotions, and so on. So let's say you have an admin console, and this admin console, as you will see, it might as well have multiple responsibilities, but I don't want to complicate the example now. I will make it simple, so I will just name this is one responsibility, and the admin console, which again I will make it small here, is one of the responsibilities. And then I just said that your online shop has a cart, so you have some kind of functionality where the users add the products and they are able then to pay them at the end. And of course there can be a specific functionality that the user, oops, sorry for that, it seems that I'm not really skilled with this keyboard yet, and the user uses this one to search for products. And then let's say at the very end, you also have an integration with some payment service providers. So your online shop offer you the possibility to make payments. And of course we might have many others, but what's the link between this online shop that I designed here, I drawn on my board, and a monolithic architecture? Well, in this case I simply consider I have only one application. That means specifically only one process that you execute. So you just have one project. You might imagine one project, say you build it with Spring. In the end you obtain a jar file, and that jar file is your executable archive, and you just run that jar file somewhere and it spins all the functionalities. Whatever client uses any of the functionalities your application implements, the same process will deal with all of them. So the admin console is inside that jar file, the cart is inside that jar file, the payments and the search products, they all are inside the same process. And when you have something like this, we say that our application is monolithical. This is just an architectural style, and I will tell you how we can change our application to a service-oriented one and what are the benefits. But let's first take a little bit of time and analyze what happens if your application is monolithical, and why maybe in the case of an online shop you wouldn't choose to use a monolithic architecture, but you'd likely use a service-oriented or even a microservices one. And is there any limit for modules? You mean functionalities in this case? No. So just when you have a monolithic application, theoretically is considered monolithic if all its functionalities are inside only one process. So if you have everything inside only one process, then you name it monolithic architectural style. You say it's a monolith. Why a monolith? Because being only one process, you can't split the functionalities. They are all together or none. You can spin up the application and have all of them, or you can leave the application not running and you have none. So if I would like to choose to say, for example, only use the cart functionality or only use the admin console, I can't do that with a monolithic architecture because the monolith cannot be splitted. That's why it's called a monolith. The analogy is very simple. A monolith is just a process that holds all the functionalities, all the capabilities of that specific software, and you cannot decide to refer to only one functionality or the other. Now, what can be wrong with a monolithic app? So the most easier to observe thing is, of course, by the definition of the monolithic architectural style, that you cannot have the functionalities apart. So because of that, you will see we have some constraints. We don't have the freedom to do some of the things that we'd like sometimes to do. But as you will also see, the monolithic architectural style has also some benefits that you can gain. So which are the benefits and which are the bad parts, the bad parts about a monolithic architectural style? So the benefits, because I like to be optimistic, I'd like to start with the benefits of a monolithic architectural style. And let's just enumerate them to remember what we discussed, and I will just put them with a comma here, with a dash here, but just make it a little bit smaller. And the first benefit of our monolithic architecture is that, well, it's very, very easy to manage when you do the deployment. So process, in this case, is operating system process. Do processes hold more threads? Yes. When I discuss about process here, I really refer to a process of the operating system. And yes, it can have more threads. So it's just like a normal application. For example, in case of Java, you have one instance of the Java virtual machine, because we know that Java applications, they run, they are executed within a Java virtual machine instance, and you have only one JVM instance that spins up, holds your application, and that one delivers all the capabilities of your application. What about binary that spawns multiple processes, so multiple JVMs? If you already have multiple processes, then we, as you will see, discuss about a service-oriented architecture, and I will discuss about the software-oriented architecture a little bit later. So for the moment, let's just focus on this monolithic architecture where all the functionalities are in one process. So usually when you discuss about monolithic architectures, you have one executable that becomes one process in the operating system, and you cannot split that apart. So that's when we discuss monolithic architectures. And of course, being only one executable, one process, as we discussed, then you will have a simplicity in deployment. So you have to agree with me that if you have less processes, then understanding your application is easier as well, and deploying it is easier as well, because yeah, you only have one executable jar. That's one, you have to run it, and you have the application. You have only one thing to configure, so it's a lot simpler, as you will see, than if you have multiple processes, because if you have multiple processes, then of course you need to deal with all of them, and you will, even as we will discuss in next episodes, you will have to orchestrate them, and orchestration is done with specific software, and orchestration can be done with virtual machines, but it can be done with containers, and we'll have a lot of things to discuss. But if you have a monolithic app, then you can orchestrate it, of course, but whether you choose to orchestrate it or simply manually deploy it, is the simplest way you can have because you only have one executable. Then whenever we have communication between the capabilities, so maybe you asked yourself, is sometimes does it happen that the capabilities implemented by a specific app talk one with the other? Do they communicate one with the other? Do they need to call each other? And the answer is yes, they do need to call each other as well. For example, whenever a user searches for products and the products are displayed, then the products need to be added to the cart because the user wants to buy them, and then the cart then needs to be used by the payments somehow, or communicate with the payments capability so that everything that's in the cart can be paid and then delivered. And then say you might have a different capability that takes care of the deliveries, which needs to as well take information that was processed by other capabilities. So it always happens that these capabilities communicate one with the other. They are not independent. And because they are not independent and they need to communicate, in case of a monolithic app where all of them are inside the same process, then to call each other, it's usually simply method calls. So just imagine you have one or more methods in the card functionality or in the search products or in the payments that can call one other method or other methods implemented in the others. So it's simply as method call between objects in this case. And method calls are very fast and they are very reliable. So in case of monolithic architecture, method calls makes communication between the functionalities inside the monolithic app very reliable, and that's again a benefit. Of course, very fast, first of all, because the information is simply exchanged inside the same process, but also very reliable because the method call can't simply fail in many cases. So if it was once working, it will be working later as well, which is, as you will learn when we discuss about the service-oriented architecture, not the case in these kinds of software-oriented architecture where the capabilities are implemented as different processes and they have to communicate one with the other externally. And usually they communicate one with the other via the network. And as you will learn when I will teach you in the next episodes, network is never 100% reliable, first of all. So you cannot just rely on the fact that always a communication done through your network will work. There are cases in which the communication will fail, and then architecturally you need to take the decision, what should I do if service A cannot call service B? What should I do in that case? And in some cases you simply do nothing, but in other cases you have to do complicated things like sometimes retries, and in other times you would implement different patterns like circuit breakers, for example. So we will have to discuss all these things, but that's not the case here of our simple online shop, because being monolithical, we only have method calls, so we can rely on them. So that makes this a benefit of the architecture, of the monolithic architecture. So maybe it's better if I wrote here already that what we discussed now are benefits. So this is what's usually good with the monolithic architecture. And then of course we have the things that are not so good. So in this case, what can go wrong when using a monolithic architecture? What are the concerns? I don't want to use a bad word here, so a negative word. I would like to use something that is not negative, because it's just the concerns we need to have when implementing something monolithical. And the main concern that affected usually monolithic architectures and that made a lot of systems, especially big systems, have to go for a service-oriented architecture instead, then raising my volume, hope that's better. So what we need to take into consideration is that the fact that the functionalities, the capabilities are not independent, this is one of the worst things about monolithic architectures, because when you have a small application, then you might have one process that deals with everything. But when your application has a big number of users that generate a big number of requests, that generates further a big number of transactions and different ways to process data in parallel, you cannot simply use one process anymore. So you will have to make use of multiple processing power, and to do that you will have to basically replicate the instance. Instead of running only one instance of your application, you will have to run the application multiple times, and that's what we will call the scalability of the application. So the first concern is that a monolithic application is more difficult to scale. Maybe I need to actually, instead of defining here scalability, which is basically the quality, I would just say more difficult to scale. And of course, to explain what this more difficult to scale is, I would like you to imagine that when you have a server, say you only use one, let me see if I find a nice icon for a server. Browser and database is not what I'd like to use here. So I think I had a server here. Okay, here it is. So this is a server. This is it might be a hardware machine. We'll discuss later that you might actually have a virtual machine, but it doesn't really matter. You can just imagine for the moment that this is basically a computer that executes the process, which in your case is a monolithic process. So imagine that you have a number of users here and you execute the process that I can actually draw as a star here. This is my process, this is my monolithic process, and I'm executing it on this platform. So what can happen if I only have a process executed on only one hardware platform? So in this case, multiple things can happen. First of all, it can be that the server fails for some reason. It can be that the server is disconnected from the network and it's not accessible anymore. It can happen that the number of requests that are coming to this process are so many that simply the process cannot resolve them anymore in a decent time, so that then it might even happen that the process gets stuck and fails. And in all these situations that I enumerated, you need to make sure that somehow you can have multiple instances of the same processes that can either take the responsibility of responding to the requests, whenever the requests cannot be are too many, or responding to the requests whenever the one of the other processes fails and cannot respond. So thank you very much. I'm not really an artist, but I just try to explain as good as possible here what I want to say. So what you want in the end is to make sure that you just have multiple systems, and on these multiple systems you're running the same process. Because, for example, if this one fails and is not accessible anymore, then you will still have two others that will be able to respond. If you have too many requests and only one hardware system cannot answer to all of this, then you will have two others that will compensate and will take a part of the requests, and we will respond to them. And this is basically what we call horizontally scalability. Because I will discuss in detail about scalability in one of the next episodes, I don't want now to go into a lot of details, then more just giving you the idea of what scalability is. So in this case, I think you understood some cases in which you'd like to make your application running on different platforms and not only one. But what happens, we achieve these multiple instances of services in microservices, not in microservices, in service-oriented architectures in general, because as I will tell you in the next episodes, microservices, and maybe I should have just put it like this, as well as functions, well, they basically rely in terms of architectural style somewhere in the service-oriented architecture's scope. So microservices is just a more particular way to implement a service-oriented architecture. Function as a service are again just services in a service-oriented architecture, but it's a more particular way. So I would say, to be more general, I would say we can achieve that better with service-oriented architecture indeed, as we will discuss in the next episodes. But you can do this with monolithic applications as well. You can just run the processes, the same process, on multiple machines. That's not a problem. But it's more difficult. So observe here that in the concerns, I didn't say it's impossible to scale a monolithic application. I said just that it's more difficult to scale it. So you can scale a monolithic application, but as you will see from our discussions, scaling a monolithic architecture is more difficult, while a service-oriented architecture makes it easier, as you will see in the next videos. Why is it more difficult, you will ask? Why is that more difficult to scale a monolithic architecture? Because scaling a monolithic architecture means scaling absolutely everything always in terms of capabilities. Remember that by definition, and that's what I introduced from the very beginning, by definition, a monolithic architecture is a process containing all the capabilities of that app. So when you replicate the process, you will replicate all the capabilities. You can never take the decision with a monolithic app to just, for example, scale this part of the system. So if you wish to only scale, only move here and have twice the payments functionality executing, that's not possible in a monolithic process, because they are linked in the monolith and they cannot be split apart, because that's the definition of a monolithic architecture. So it's more difficult, first of all, because you always need to scale everything, and that process, that monolithic architecture process, it might become very heavy. Putting everything in there, the application might get to millions of lines of code, and I don't exaggerate here. I've seen myself monolithic architectures, and I've seen old applications that even had millions of lines of code. And the heavier they become, we call this the footprint of the application. The heavier they become, the more difficult it is to start them up. You will see when we discuss the deployment, the more difficult it is to compile them and to package them and to test them. And the longer the time is needed from the development to the deployment, the more difficult it is to make the application scalable as well. So it's not only the startup, but you will learn throughout the next episodes that even the fact that the compilation and the packaging and the testing of such applications take longer time makes it more difficult to integrate them in a continuous deployment and delivery process, and that affects the way we work as well. I discuss about, thank you very much, I noted you also have to share the state between processes. I will discuss this just now. So sometimes, and I will say sometimes, Gabi here tells us that you also need to share the state between processes. I avoided to discuss this first, but I will put it here as well as our next concern about monolithic architectures. Does it have a state? And mind that I just say, does it have a state? Because I don't want to say that all the monolithic architectures are stateful. It might be that you implement a monolithic architecture that's not stateful, and then you don't have any concern. But you always have to consider if your monolithic architecture might or not store something in memory. That's called a state. So if through a request you store something in a specific process, then all the other requests that depend on that information, they will never be able to complete if they don't go to the same process. And in the next video we'll discuss, one of the things we will discuss is the management of the state in case of stateful applications, which monolithic architectures usually tend to become stateful, as you probably were thinking when you written that in the chat. Okay, so that's again what I was discussing. So now our discussion is almost over, and I don't want to start this discussion now, but in the next video I will tell you about at least 3 ways in which you can share the state between monolithic architectures. I will enumerate them now, but I will leave the mystery for the next video when we will discuss them. One of them is the possibility of using what we call sticky sessions. Sticky sessions are a way in which we know when a client set a state on one specific instance, and we make sure that that client only goes with requests to the same instance. A second one that we'll discuss is called blackboarding. And blackboarding is using a database to store the state between multiple instances. And the third one is sharing the state through direct communications between the instances. These are the 3 more important ways in which we deal with statefulness, which is one of the big deals of monolithic applications. But I will detail this in the next episode. Now, I don't want to end the episode until I do discuss, at least enumerate, all the concerns and not only the benefits of the monolithic application. So besides being more difficult to scale, which also implies not only the fact that it becomes heavy, it has a big footprint, but it's also heavier to compile, to package and to test, which are, as you will see, actions in our continuous delivery pipeline. The fact that the monolithical application might have a state, you will see when we discuss server-oriented architectures, is less probable that the applications have states. In most cases, in monolithical architectures, they have states, and we have different ways that we'll discuss in the next episode to deal with the state. The last concern is the way the application is written. Because when you have a monolithical application which has everything together, one of the biggest problems that I often encountered is that the functionalities tend to go one within the other. They are not separated anymore. You know, we have one very important principle that is called the single responsibility principle. It's part of 5 principles that all together we name solid. We will, again, this will be also part of our discussion in one of the next episodes, but shortly now, the single responsibility principle tells you that in a system, in an app, and even in a class, you need to have components that implement only one responsibility, and that responsibility is decoupled from other responsibilities. And usually what happens is that because you have all the code in the same application, then it's very tempting for developers and especially for beginners to just go and implement some things of a responsibility in another in code that should implement and that resembles another functionality and another responsibility, and that's how usually the maintainability of an application is affected. When you write it monolithically, it's more difficult to avoid clean coding anti-patterns like spaghetti code, lasagna code, phantom objects, I don't know, a big ball of mud, poltergeists. And again, don't worry if you don't know what these are, because it's also part of this stream that we discuss all this. But in a monolithical architecture, it's very, very possible to fall into the dark side and implement the code in a less clean way, implement the code in a muddy way. Copy paste adopt pattern, of course, that's again another one. So it's basically very tempting to do that. And we have ways in which nowadays is more recommended if you implement a monolithical architecture to do is by implementing it modular. And I will discuss again that, I will discuss it in the next video, what modularity is and how can your monolithical architecture benefit of the modularity to avoid situations in which you implement your class design and your code in a muddy way. But what is important still to understand is that it doesn't imply that the monolithical architecture needs to be muddy, needs to be not clean. So you might have a monolithical architecture that is very clean and very well written with a good and strong class design. That's only a job of a developer to make it like that. And that's why, even though this is most probably the main reason why it seems that in literature the monolithical term became a synonym for legacy or for muddy code or for not well written code, is because the fact that the way you write monolithical application is more dragging you more into writing bad code. And because in the past we didn't have principles, because usually a lot of applications in the past they started as monolithical applications. There was not something like software-oriented architecture 20 years ago. So in an old application, in an old monolithical application, mainly not because of its monolithical approach, but because of the fact that when it started to be implemented, developers didn't know and we didn't have these principles, these clean coding principles that we call now solid, keys, Yagni, and so on and so forth, dry. We know what anti-patterns are, we have design patterns that we can use when relevant. We didn't have that 25 years ago. And that's why those applications that started many years ago, they now look this way, not because they were implemented as monolithic apps, but because the developers didn't have the principles and didn't know them so that they can take care about the maintainability. Now we know these principles, we learn them, and it's easier for us to judge. But when you think about the past, think that it was not a developer problem, that they didn't have all these things that we actually discovered throughout time. So will you discuss about CAP theorem in one of the future lessons? Yes, that will be probably and most likely when we discuss data persistence and databases, because it's a theorem that is directly related to databases. The consistency, availability, performance, that's what CAP stands for, and that's for everybody to know what CAP is. We'll discuss it when we discuss the persistence. So CAP is a nice theorem. We will discuss the fact that you can't have consistency, availability and performance all at once when persisting data, but I will again leave the mystery for one of the next episodes because it's a long discussion, and I want to make sure that I discuss everything that's relevant about it. And cloud computing also helped microservice architectures move into the mainstream. Yes, I agree with you, Tudor. So indeed, cloud computing and evolution in general. I didn't basically discuss in this lesson the evolution of software architectures, but it's one of the things I would like to maybe next time on one of the next videos to share with you. I would like you to have an overview not only on the technicalities but as I said at the beginning of this video, also on the history itself, because you will see that the fact that we have software-oriented architecture is first of all the fact that we have a good internet connection. 25 years ago, if you would have told the software architect that you want to split the solution into two apps that communicate via the network, it would tell you are crazy, because you had DSL modem connection, and so it wouldn't have been possible to simply reliably even send a small quantity of data. So that wasn't a solution. So it wasn't a solution not because of the fact that the developers didn't know how to split their apps and make them communicate, but because they didn't have the proper environment to run that. They didn't have a good internet connection or good networks to make that service-oriented architecture reliable, so that those services really communicate one with the other. So that's why a monolithic approach at that time was not only a good approach, was the most relevant approach from many perspectives. So that was the first thing. I'm not even thinking about cloud computing, because at that time, not only that they didn't have cloud, they didn't have a proper networking. So that was the first thing. The first thing that helped in the evolution of software architectures from monolithic to service-oriented is the evolution of networks. And in general, the evolution of the environments, because we'll discuss many other things relevant to that, not only the network in terms of infrastructure, but also the virtual machines that appeared and that again help in make the implementation of software architectures, of service-oriented architectures more relevant, and so on and so forth. Deployment affects the entire business by stopping all functionalities. So that is something that I thought I covered here when I discussed about the availability, but yes, maybe it worths that I put a separate point here as Gabi suggests, availability, which in short, in a sentence or two, if you have only one app and that process implements all the capabilities, if this one fails, then everything fails. So if, as you will see when we discuss service-oriented architectures, they are independent and only one of them fails, then you affect only one side of your enterprise and not all of them. We will dig into this later, so we will discuss more things about it. So, is monolithic distributed system? I will take this question of the distributed system again a little bit later when I discuss all the kind of architectural styles, because it's debatable, and now I didn't discuss plenty of things to be able to cover it. So allow me to take that question with the monolithic and versus distributed system a little bit later when we have more information in one of the next videos. But I think we covered the main benefits and concerns on monolithic applications, and I still have plenty of things that I'd like to discuss about monolithic applications, but in general I would like to also be able to compare them with the next architectural styles that we will discuss. So in the next video we will discuss first of all possibilities of solving these concerns on monolithic applications. So the monolithic application is more difficult to scale, but can we do it still? The answer is yes. Let's see in the next video how and which are our possibilities to still scale our monolithic application. Can we make it available? Yes, it's more difficult to make it available. Again, maybe here I shouldn't just stated availability. I would just should have stated more difficult to make it fully available. If it has a state, can we manage that state? And how can we make our application still maintainable and keep it maintainable and force the developers keep it maintainable even if it's monolithic? So what we will do in the next video is discuss these concerns and see what can we do about them in case of monolithic applications. And once we have discussed these concerns, we will go to the next architectural style, the service-oriented architecture. And then we will be able to compare the monolithic architecture and the service-oriented architecture. And then we'll go to microservices and functions as a service and serverless in general. I will schedule these videos weekly, as you probably used already with me doing. So I will have this series with episodes every Friday at the same hour you found me today. And yes, let's stop this for today. Thank you so much for all your questions. And again, testing and all the other advantages, Daniel, let's discuss them in the next video. We have plenty of things to discuss. I hope you saw that we have plenty of things to discuss. So I hope this will be a stream that will give you plenty of ideas and you will learn many things. And again, let's meet in the next episode, and up to that time, have a great time for study further. Cheers everyone. Thank you.